Ferrari has just exposed the direction of its radical SF-26, and what happened during the team's first Formula One laps around Madrid's new Madrid circuit could change everything before Spa. This was only a restricted filming day. Limited mileage. Special tires. No full qualifying simulation. No complete race program. But Ferrari still gained something no rival had. Real track data. Real driver feedback. And the first chance to discover whether the car's most dangerous weakness had finally been fixed. Because only days earlier, Lewis Hamilton took sprint pole at the British Grand Prix, then admitted that a setup mistake made his magic disappear. Now Ferrari may know why. The speed was never the real mystery. The real mystery was why one small adjustment could make that speed vanish. And if the Madrid data revealed what Ferrari believes it revealed, Hamilton and Charles Leclerc could arrive at Spa with a car that is not only fast, but finally predictable. But one hidden detail from that first lap suggests the breakthrough may come with a serious warning. Subscribe to the channel. To understand why Ferrari's first laps around the Madrid mattered, you have to stop looking for a dramatic lap time. Because the stopwatch was never the main target. This was a filming day. The running was restricted. The mileage was limited. The tires were not the normal Grand Prix tires. Ferrari could not spend the entire session testing every setup direction or completing a full qualifying and race program. So one fast lap would not prove the SF-26 had suddenly become the strongest car on the grid. But one honest reaction from the car could still reveal something much more important. Whether Ferrari truly understood it. Before the car reached Madrid, Ferrari's engineers had already spent months working through simulation. They could predict how the airflow should move. They could calculate how the car should respond under braking. They could estimate how the balance would change as the driver turned into a corner. They could model thousands of situations without the car ever leaving the factory. Then the SF-26 rolled onto the Real circuit. And reality began answering back. The track surface was not perfectly smooth. The wind did not remain constant. The tires moved under load. The car vibrated. The driver made tiny corrections. Every one of those details could expose something the simulation had missed. That is why the first lap was so valuable. Not because it proved Ferrari was fast. Because it showed whether the real car behaved the way the engineers expected. Imagine building a key from exact measurements. Every angle appears perfect. Every number says it should fit. Then you place it inside the lock. If it turns smoothly, the design earns trust. If it catches, even slightly, every measurement must be questioned. Ferrari's first Madrid lap was that first turn of the key. Did the front respond immediately? Did the rear remain calm under braking? Did the balance stay predictable as the driver increased speed? Did the SF-26 match Ferrari's digital model? Or did the new circuit expose a reaction the team had never predicted? That was the real test. And Ferrari had one major advantage. It became the first Formula One team to run at the Madrid. Every rival still depended on maps, models, and simulation. Ferrari had the real surface, the real braking zones, the real changes in direction, the real bumps, and the real feedback from inside the cockpit. But being first also created a serious problem. There was no Formula One reference, no previous Grand Prix, no old setup, no established tire pattern, no rival lap to compare. Ferrari gained exclusive information. It also gained exclusive uncertainty. If the rear moved unexpectedly, was the SF-26 unstable? Or was the surface offering less grip than predicted? If the driver corrected the steering, was the front refusing to respond? Or was the ideal racing line still being discovered? If one braking zone looked difficult, was the setup wrong? Or had the simulator underestimated the corner? One movement could have several explanations. And that is why Ferrari could not trust one clean lap. One lap can flatter a car. Fresh tires can hide a weakness. A favorable gust can improve one section. A careful driver can make an unstable machine look calm. Ferrari needed repetition. Did the same behavior return? Did the car react logically after a setup change? Did the driver report the same feeling again? Did the sensor data support what the driver felt? Repeated behavior creates evidence. And Ferrari needed evidence more than excitement. Because only days earlier, Lewis Hamilton had already shown what the SF-26 could do when everything aligned. He took sprint pole at the British Grand Prix. For that session, the balance worked. The confidence was there. The connection between Hamilton and the car looked strong. Then the setup direction changed. Hamilton later said his magic disappeared. That phrase was not a technical explanation. It did not identify a wing angle. It did not reveal a suspension setting. It did not explain the exact aerodynamic balance. But it revealed something even more important. Hamilton had lost access to the car's performance. The speed may still have existed inside the machine. But the driver could no longer reach it with the same confidence. And when confidence disappears, the lap begins to fall apart in tiny pieces. A slightly earlier lift. A slower steering input. A delayed return to the throttle. One extra correction. None of those moments looks dramatic. But across a full lap, they become the difference between attacking the front row and fighting much further back. That is why Ferrari's most dangerous problem may not be a lack of speed. It may be the difficulty of keeping the car inside the exact conditions where that speed appears. That is the operating window. The phrase sounds technical. The idea is simple. A wide operating window means the car works across many conditions. Hot track, cool track, fresh tires, used tires, heavy fuel, light fuel, changing wind, different setup choices. A narrow operating window means almost everything must be perfect. The tires must reach the correct temperature. The ride height must remain inside a small range. The aerodynamic balance must sit in one precise area. The driver must approach the corner in exactly the right way. Move slightly outside that window, and the performance disappears. It is like balancing a glass near the edge of a table. When the glass sits safely in the center, a small movement changes nothing. When it sits close to the edge, one tiny touch can change everything. Ferrari may already know where the fastest version of the SF-26 exists. The frightening question is whether that area is wide enough to survive an entire Grand Prix weekend. And Spa will test that question from every direction. Spa does not ask the car to do one thing well. It asks the car to do almost everything. The SF-26 needs low drag on the straights. It needs stability through fast corners. It needs strong braking confidence. It needs traction. It needs to remain predictable as the circuit rises, falls, and changes direction. Ferrari cannot maximize all of those things at once. More wing creates more grip, but more wing creates more drag. Less wing improves straight-line speed, but it can make the car nervous through the faster sections. A sharper front end can help rotation, but it can also make the rear harder to control. More rear stability can give the driver confidence, but it may leave the car unwilling to turn. Every setup decision gives something. Every setup decision takes something away. That is normal. The danger begins when one small change creates a much larger loss somewhere else. And Hamilton's British Grand Prix experience suggests Ferrari may already have felt that danger. The car reached sprint pole. Then the magic disappeared. That does not prove the SF-26 has a fundamental flaw. Ferrari may simply have moved away from a strong baseline. But the difference between those two possibilities is enormous. A wrong setup can be reversed. A deep design sensitivity may require development. If Ferrari's Madrid data showed the car reacting logically, then the British Grand Prix could be viewed as a wrong turn. Painful, but correctable. Ferrari could return to the known balance. Make smaller adjustments. Protect the characteristics Hamilton trusted. Give Charles Leclerc room to move the car toward his own preference. But if the same sensitivity appeared at the Madrid, the concern would become much deeper. Then Ferrari would not be dealing with one bad setup choice. It would be dealing with a car that may only perform inside a very narrow range. And Spa could expose that weakness immediately. The long straights would punish excess drag. The fast corners would punish instability. The braking zones would punish hesitation. The changing weather would test whether Ferrari could keep the tires and balance inside the correct window. One small mistake could spread across the entire lap. That is why Ferrari's first Madrid laps were more than ceremonial. The team was not simply introducing Formula One to a new circuit. It was investigating whether the SF-26 responds logically when reality begins challenging the simulation. This process is called correlation. The word sounds complicated. The meaning is simple. Did the real car behave the way Ferrari predicted? When the answer is yes, the engineers gain confidence. They can trust the simulator. They can prepare setup changes with greater certainty. They can design future upgrades knowing the factory tools are pointing in the right direction. But when the real car and the simulation disagree, doubt spreads quickly. Was the setup wrong? Was the model wrong? Was the track surface different from expectations? Was the driver still learning the layout? Was the restricted filming day program hiding part of the story? One unexpected reaction can create several investigations. And every investigation costs time. Ferrari cannot afford to arrive at Spa still asking basic questions. The team needs a clear baseline. Hamilton and Leclerc need confidence early. The engineers need to know which changes are safe. And Ferrari must decide whether to chase peak performance or protect consistency. That choice could define the entire weekend. The fastest theoretical setup may not be the strongest setup across qualifying and the race. An aggressive balance might produce one spectacular lap, but it could become unstable as the tires wear. A calmer setup might sacrifice a small amount of peak speed, but it could give the drivers more confidence as the conditions change. One option creates a higher peak. The other creates a stronger average. And across a full Grand Prix weekend, the stronger average may be far more dangerous. That may be the direction Ferrari was truly searching for in Madrid. Not the setup that looks fastest for one moment. The setup that remains understandable when everything begins to move. Because an understandable car gives Ferrari options. A fragile car gives Ferrari warnings. And somewhere inside those first Madrid laps, Ferrari may have learned whether the SF-26 is a flexible platform, or a car still trapped inside one painfully narrow window. If the real data matched the simulation, if the behavior repeated, and if the drivers could feel confidence without sacrificing speed, Ferrari may have found the foundation it needs before Spa. But if every improvement created another weakness, if the car changed personality as the setup moved, or if the data refused to match the prediction, then Madrid may have exposed Ferrari's deepest problem. The speed exists. The challenge is controlling it. And that is where the next stage becomes even more dangerous. Because Ferrari now had to decide whether the first Madrid signals were strong enough to shape the entire Spa setup, or whether trusting them too early could send the team straight into another mistake. And that decision was far more dangerous than it looked. Because once Ferrari chooses a setup direction for Spa, every later adjustment begins from that foundation. If the foundation is correct, the team can refine the car. A little more front response. A little more rear stability. A little less drag. Small changes. Clear reactions. Controlled progress. But if the foundation is wrong, Ferrari could spend the entire weekend moving further away from the answer. That is the hidden risk behind the Madrid data. The filming day may have revealed something useful. But Ferrari still had to decide whether the lesson belonged to the car, the circuit, or the limited conditions of the run. That distinction matters. A setup that feels stable at the Madrid may not behave the same way at Spa. The corner speeds are different. The braking demands are different. The aerodynamic loads are different. The weather can change quickly. The tires will face a completely different challenge. Ferrari cannot simply copy what worked in Madrid and expect the same result. It has to understand why it worked. That is the real test of engineering. Not repeating the same settings. Repeating the same behavior. Ferrari needs the SF-26 to give Hamilton and Leclerc the same confidence, even when the circuit changes. That means the car must respond logically across different environments. A stable front end in Madrid must not become lazy at Spa. A calm rear in Madrid must not become too restrictive through faster sections. A setup that protects the tires during limited filming day running must not leave the car slow on a full race weekend. The numbers may change. The feeling should remain understandable. That is what Ferrari was really trying to carry forward. But here is where the pressure increases. Spa does not allow the team to hide a weak compromise. If Ferrari chooses too much aerodynamic support, the car may feel secure through the corners. But the straight-line speed could suffer. That makes overtaking harder. It makes defending harder. It can leave both drivers trapped behind faster cars. If Ferrari removes too much wing, the SF-26 may become quick in a straight line. But Hamilton and Leclerc could lose confidence through the faster corners. And once confidence disappears, the time lost can be greater than the speed gained. That is the balance Ferrari must find. Not maximum grip. Not maximum top speed. The point where the complete lap becomes strongest. And that point may be different for each driver. Hamilton may need a rear end that stays calm as he releases the brakes. Leclerc may want a front end that reacts immediately. Hamilton may accept slightly less rotation if the car gives him confidence. Leclerc may tolerate more movement if it allows him to attack the corner harder. Ferrari must support both without creating two completely different cars. That sounds obvious. It is one of the hardest problems in Formula One. A setup that unlocks one driver can confuse the other. A development direction that improves one side of the garage can create doubt on the other. And when the car has a narrow operating window, those differences become even more severe. Ferrari does not only need speed. It needs flexibility. The SF-26 must allow different setup choices without losing its basic identity. That is what a strong platform does. It lets the team move the balance. It lets the drivers find confidence. It lets the engineers respond to weather. It lets Ferrari adapt. A weak platform does the opposite. Every adjustment feels dangerous. Every new setting creates another problem. The drivers begin protecting different weaknesses.